Introduction. The sky that we watch every night is full of thousands of stars, but in reality, what we see with our naked eye is just a tiny part of the universe. The universe is so big that most of the distant objects are not visible to us. However, certain objects are so powerful that despite their immense distance from us, we are still able to detect them, although only using telescopes. I'm talking about quasars or quasi-stellar radio sources. Do you want to know what they are? Watch this video and I will tell you more. The discovery of quasars. The discovery of quasars dates back to the 1950s, and it's interesting to look at the history of their first observations. In the 1950s, astronomers started to look at the sky using radio telescopes for the first time. Radio telescopes, contrary to normal telescopes, detect radio waves instead of visible light. When astronomers first started to watch the sky with these instruments, they were surprised to find several objects emitting a large amount of radio waves but almost no visible light. In fact, most of these sources of radio waves did not correspond to any known visible object. The first quasar ever discovered was 3C273, a weird name indicating the 273rd object in the third Cambridge Catalogue of Radio Sources, 3C. It was discovered thanks to a lunar occultation, an event that occurs when the moon passes between an object and the Earth, hiding the object from our view. In 1959, a group of astronomers at Cambridge University identified a radio source in the sky, 3C273, but they couldn't find an optical counterpart to it. 3 years later, in 1962, John Bolton and his Caltech radio astronomy group used the Parkes radio telescope to conduct a series of observations of the sky during which the moon was passing in front of the radio source discovered 3 years earlier. Thanks to these lunar occultations, Bolton and his group were able to calculate the location of the source with precision. More importantly, they were able to associate it with a visible counterpart, a faint object. Later on, new quasars were discovered. Generally, their position in the sky matched with very faint objects, like very distant stars. That's why they were called quasars, a contraction of quasi-stellar, star-like, and radio source. However, the chemical composition of these objects, observed by looking at their spectral lines, was very different from any known star. Also, the amount of radiation emitted by them was too large for them to be normal stars. The observation of these quasars continued throughout the years. By observing their radiation spectrum, scientists found out that these objects were moving very fast and away from the Earth, a phenomenon known as redshift. What is redshift? Every object in the sky emits radiation in a broad range of frequencies, including in the visible part of the spectrum, which consists of different colors: violet, blue, green, yellow, orange, and red. The color that our eye perceives depends on the frequency of the light that we observe. Violet corresponds to the highest frequency, while red corresponds to the lowest one. While the light emitted by an object in the sky contains a mix of different frequencies, it has a peak at a certain color. If we look at the sky, we notice that some stars appear red, while others appear blue. However, when the object we are looking at is moving relative to the Earth, the frequency of the light emitted by the object appears different to our eyes. In particular, if the object is moving towards us, the frequency of its light appears to increase, and therefore it becomes more bluish. This is known as blue shift. Instead, if the object is moving away from us, the frequency of its light appears to decrease, and therefore it becomes more reddish. This is known as redshift. When scientists observed the radiation spectrum of these quasars, they observed a large redshift, which meant that these objects were moving away from us. Not only that, but they also found out that these objects were extremely distant from us. This information can also be inferred from the amount of redshift. In 1931, the famous astronomer Edwin Hubble observed hundreds of galaxies and discovered that their velocity was proportional to their distance from the Earth. In other words, the larger the redshift of the light coming from those galaxies, the faster they were moving away from us and the more distant they were. This result is known as Hubble's law, one of the most important results in astronomy. By applying Hubble's law, scientists in the 1960s found out that the quasars they were observing must have been very distant from the Earth. Some of them were even 10 to 20 billion light-years away. This put quasars immediately among the farthest known objects. What are quasars? Now that we've learned a bit about the history of quasar observation, we may wonder, what are quasars actually? Quasars and black holes. The main problem in the observation of these quasars was explaining how they could generate such huge amounts of energy. In fact, some of these quasars were visible despite their enormous distance from the Earth. There was no known mechanism to explain that, so scientists had no idea what these quasars were. The explanation was proposed by Ed Salpeter and Yakov Zivik in 1964. According to them, quasars were supermassive black holes surrounded by large amounts of matter. But wait, we actually know that light and any other form of radiation cannot escape a black hole, so how could these objects generate such huge amounts of light and energy? The reason is that the energy of a quasar is actually produced outside of the black hole. The supermassive black hole is surrounded by a huge amount of matter in rapid rotation around it and falling toward it due to the immense gravitational force exerted by the black hole. This matter undergoes extremely strong friction, and as a result, it emits a lot of energy as radiation in different forms such as radio waves. This matter in rotation takes the shape of a disk known as an accretion disk. The amount of energy produced through this mechanism is very high. When this matter falls toward the black hole, between 6% and 32% of its mass is converted into energy. As a comparison, less than 1% of the mass is converted into energy in the nuclear reactions inside our Sun. Indeed, quasars are among the most powerful and energetic objects in the universe. A quasar can emit an amount of energy equal to 1,000 times the amount of energy emitted by the entire Milky Way galaxy. Despite this, given their enormous distance from us, quasars are too dim to be observed from Earth with normal telescopes. However, if we could place one of these quasars at the same distance as the Sun from the Earth, it would shine 1,000,000,000,000 times brighter than our star. Final thoughts. This video ends here. Thanks for watching, everyone. Did you find quasars cool? Is there something else you want to know about them? Let me know in the comments below. Be sure to subscribe and I'll see you next time on the channel.